So today's learning goal, I can analyze data in tables and graphs, and I can choose a table or a graph to display that. So first of all, analyzing what's already been given to you in a table or a graph of some form. You know what tends to happen? We tend to look at these graphs and these tables and stuff, and we seem to think it's so easy to just pick out information out of them that we tend to make mistakes because we don't read carefully enough all the information that the graph is providing. First of all, we have to have an understanding of how the graph is set up and what's being represented how, and we have to analyze it. And then we also have to analyze the question they're asking us. Sometimes we just look and something stands out that says how many boys, and you just answer. And you don't pay attention to what were they really asking. You don't take enough time. And so then you're getting things that you thought were so easy wrong, because you just thought it was just that easy to grab it out of the graph. And typically, it really isn't all that hard. But we have to make sure that we are, first of all, making sure that we understand what the graph is representing and how it's representing it. And then we have to make sure we read really carefully what was the question that they're asking us. The other thing you have to be able to do is if they give you some data and they ask you to make a graph for it, you have to be able to say, this would be the best representation of this data. It would be the best seller of the information, which is, trust me, that's how it is determined when, especially, newspapers and internet articles and magazines or wherever you're going to see these, when advertisers use them, wherever they use them, they have to make something that's going to grab your attention and show the information to you well. So let's start though by ones that are already made for us. So up here in our first one, comparisons between two groups can be made easily on a double bar graph. So let's look at our graph first of all. What's being represented on this graph? Don't make this so hard. What is being represented on this graph? Does it have a title? Yeah, Recreation Center Enrollment. Look at its title. Here's what it's representing. It's the enrollment at this recreation center. We don't know which one, but we know it's some recreation center. Enrollment means what? People who are attending, people who are signed up, people who are, a part of it. What else is going on in it? What's it comparing? It says comparison between two groups. So people who live there that are considered residents and people who are non-residents. When we go to Maple Grove to visit our daughter and son-in-law and granddaughter there, they belong to the Maple Grove Community Center. They are a resident there. So when they go, they pay a different fee than I do because I'm a non-resident. I get to pay more. Okay? So there is a difference between being a resident or a non-resident. Okay? What's being represented kind of on the horizontal axis? What's being represented on the horizontal axis? You know, some of you are not even looking at your paper. Don't ask me later to do something for you. Because I want to be like, help yourself.
Is it the activities?
The activities. So give me an example of an activity that's happening at this recreation center.
Soccer.
Soccer. Zip it now, Cody. Thank you, though, for your participation. Oh, don't get upset with me. I have 8 other people in here today that have voices also. What else? What was that? Swimming. What else? Music. Anything else? Dance. Okay, those are the 4 activities that are being represented, and that's on the horizontal axis. So what's on the vertical axis, what we call the y-axis? What's being represented on the vertical? When we're looking at the vertical axis, what are we looking at? Yeah, number of people. How many people are actually enrolled? Okay, so which class shows the greatest difference between residents and non-residents? So these are classes that they're offering. They just gave us that information. Which class shows the greatest difference between residents and non-residents? how would, how could we even just look at it and say, here's how I can just right away tell? Dance, why is it dance?
Because there's more like, residence is way higher than the non-residence.
Yeah, the resident, the white bar here is a whole lot higher than the non-resident. There's a bigger gap between the height of them, isn't there, than any of the others? So right now it appears it would be dance. Okay, so let's say dance. But then let's just, have a little bit of support for that. How many residents are enrolled in dance? 250? Everybody agree? Okay. If we have to find the difference, do we add or subtract? Subtract. How many non-residents are enrolled in dance class? 100? Do we agree with that, everybody? Okay. So we're kind of having to estimate from this graph. We say it looks like there's about 250 residents enrolled, 100 non-residents. So it appears that there's a difference of 150 people. And when you just do a kind of a quick run through of the other ones without writing it down, what's the difference between the residents and non-residents for swimming? What does it look like? Look on your papers, don't try and look up here. About how many more residents than non-residents are enrolled in swimming? How many? 75. I get 75. How about music? Maybe 10? How about soccer? 50? So it is pretty clear that it is dance, isn't it? For this question. Which class shows the greatest difference between residents and non-residents? Okay, how many more people were enrolled in soccer than dance? How many more were enrolled in soccer than dance? Did they say anything about resident or non-resident there? So what do you think we have to do? Total. We have to figure out how many there are total in soccer. So what are we going to add together? What two numbers?
350 plus
300
300.
is the white bar plus 350 for the darker bar, and that comes out to 650. Okay, so there's a total of 650 people enrolled in soccer. How about dance? We already have those numbers up here. What do we have? 250 plus 100. Now we're adding them together because we want to know what the total number of people in dance is. It is 350. So now it says, how many more people were enrolled in soccer than dance? Soccer, take away dance, and we would say 300, right? So just make sure that you're always reading the question carefully. What are they asking you to find? And then when you're making your estimates from the graph, how many, make sure you just make a good estimate, not just good enough. Okay, well, when do you decide to use a double line graph? Well, when you need to see change over time. So it says with a double line graph, you can easily see how groups change over time. So what's going on this graph? Hey, what's happening on our next graph, our double line graph? Yeah, instructor employment by gender. So in other words, the people who are employed as instructors, we're going to compare gender. Well, gender would be what? Male and female. So one of our lines is going to represent the males, and one of the lines is going to represent the females, and the vertical is going to represent how many instructors. And what's going on in the horizontal? What's that? JFMAMJJASOND. That's some crazy acronym. Yeah, months, because it says change over time, right? So you think when we look at this, the line that has what shape on it, they're gonna identify, you know, the points by what shape for the males.
Triangles.
Triangles. And what shape are they gonna use as
Squares.
the points on the line for the females? Squares, okay. So it's kind of, sometimes it's kind of hard to tell the difference between the two, so let's start answering the questions they're asking us. During which month or months were the number of male instructors equal to the number of female instructors? Julia, you got a month that the number of male instructors was exactly the same as the number of female instructors? January, right away at the beginning here, right? Right there in January, okay? Jan. Is that the only month? Is there another time, Devante? May. So May is this one right here, and it appears the two lines are intersecting at that spot. So we can say, and May. Oops, I didn't really need to have that little dash in there. I don't know what that's about. Okay. Any other spots? Any other months of
December.
December? Oh, I don't think so. Look at there. I don't think they're on top of each other there, are they?
Which things that like the start of December.
Oh, where they're crossing there, that's kind of like between times. So when you follow this up, it's not above a grid line, okay? It's not, I need a pen. It's not where the grid line is, okay? It's not like that. It's between there and there, okay? It's in between. See how the D is between the two grid lines? So I think we're probably there's only those 2 months, right? Okay, between what 2 consecutive months did the number of female instructors increase the most? Female instructors, which line are we going to look at?
The squares
One with the squares on it.
from February.
What does consecutive mean?
Over a period of time.
No. What does consecutive mean? Continuously. What's that mean? If we want consecutive months, they have to be one right after the other. Yeah, so that's kind of what I think you mean by continuously. Like, so give me an example of consecutive months. February, March, and April. Yeah. Okay. So now that we have decided what consecutive means, and the question is, what did the number of female instructors increase the most? So you make a decision here. From what to what?
From 6 to 10.
From 6 to 10. I think they said between what 2 consecutive months? Did it say between which 2 numbers? February to March. Everybody agree? So from February to March, that would be this line segment right here. How can we tell? How can we be sure? Pardon? It's the steepest line, right? It has the steepest slope. Are you convinced that it's the steepest? From February to March.
It's the steepest rising.
Okay.
It's the longest.
It's the longest. Yeah, that's true. So that would be the bigger rise then, wouldn't it? From month to month, if it's longer, but yeah. So my question, I'm kind of questioning right here. Couldn't it be that one? Yeah. How about, why not from, what is that? From March to June? How come we can't say from March to June? Or May to June? No, March, yeah, May to June.
It's because that number of female instructors increased the most.
Increase the most. So how much does it increase from May to June?
2.
Goes up 2. How many does it go up from February to March? 4. Okay, so is there ever a bigger increase than that 4 is basically what we're looking for? No, so we are going to have to say from February to March. Oops, I don't need it. February to March. An increase of 4, right? was there ever a time that there was not an increase of instructors in either gender?
Yes.
Even though this is not one of the questions, answer this for me. Was there ever a time
From October to November,
and that's for the what? Females.
And then the males.
The males always had an increase or a decrease going on?
Yeah.
Yeah.
mostly. But the females had two of them.
Well, they had two spots, didn't they?
From July to August.
If there's another spot there where it didn't change at all, did it? Horizontal means no change over the time, right? There's no increase or no decrease. Okay, let's go down here to our next one. And I want you to answer 5 through 7 on your own. Analyze the graph first. And then start reading the questions and make good decisions. For both 6 and 7, you should be able to support your answers also. Okay, Julia, you can fill in your answer for 5, please. Just right with your finger. Volunteer for 6. Michaela, come on up. Okay, thanks. Volunteer for 7. Cody. Okay, thank you. Okay, start. Decide if we agree with all these people. Number 5, which method of transportation is used most by students? Do you agree with carpool? What on the graph supports carpool? Julia, you want to justify that for us? Yeah, it's got the highest bars for both of them. So just looking at the graph, you should be able, without even having to do anything with the numbers, say it's carpool. That's the same for Valley City, right? High school. Most students come by carpool. They all drive the car full every morning. Oh, I know, you all walk. No. You ride the bus. You come in your own car. Maybe there's one other person there with you, huh? Okay. How many more girls than boys walk to school? Do you agree with that answer, number 6? 4?
Yes.
Okay. And looks like Michaela said, well, there's 9 girls that are walking to school and 5 boys that walk to school. So yeah, there's 4 more girls than boys that walk. How about number 7? How many more boys go by car or ride in a carpool? How many boys go by car or ride in a carpool? Do you agree with Cody? It's 22. Why do we add them together? Cody, put your head up and stop. Why do we add them together, Cody?
Because it's asking if they ride in a car or ride carpool, they're still in a car. They're still going to one place.
Yeah, in a car or in a didn't say how many more boys ride in a car, and how many boys, so we need to add together. So we have to make sure we really read the question carefully, and we're not doing a subtraction problem when we should be doing an addition problem, or vice versa. Okay. Any questions on? So again, as easy as this seems, it's so easy, especially when you're taking those math tests, which we'll be doing next week, or you're taking a more important test even yet as a junior next year, when they have questions like this on there, and you're just like, oh, this is so easy, and you just race through it, and you don't really analyze the graph well enough, or the question even that they're asking. Okay, so number 8, which category accounts for the highest percentage of the monthly budget? Run the new graph. What kind of a graph is that, first of all? Pie graph, also known as a circle graph, known as a pie chart, we can call it. Yeah. So, which category accounts for the highest percentage of the monthly budget? Savings. They're going to put the most into savings. What are 2 different ways we can make that decision? Just by looking at it, it's the biggest piece of pie, and it's the highest percentage, isn't it? Yeah. Okay. 9. Which categories account for the smallest percentages of the monthly budget? Yeah, it's a tie between clothing and entertainment. So clothing and entertainment get the least amount of money budgeted for them. That might not work in my household. Number 10, if the budget is $500, how much is spent on food? Well, we're going to show our work here before we use our calculator. So what would we do? I'm sorry, what? Could I have somebody raise their hand and talk to me, just one person, because I'm not very good at deciphering between 2 or more. You can talk when, thanks Noah.
Would we divide 500 by 0.2?
Okay, divide 500 by 0.2. Let's try it. Let's do it. Get your calculators going now. What's 500 divided by 0.2? 2,500. Okay, you think that seems reasonable? A $500 budget. Going to spend $2,500 on food. Is that possible?
We can multiply it by 0.2.
Okay, so let's see if that seems more reasonable. What's 500 times 0.2? 100. Now, does that seem to make more sense that if this whole pie is $500, that $100 would get spent on food? Yeah, so when we, first of all, we have 20% that we're going to show. We changed to a decimal. We did this in our homework for today. What's 20% as a decimal? 0.2. Okay. So now you said we're going to multiply by 0.2 because that made more sense. And that is 100. And that's 100 food? $100 spent on food. Okay. If 20% is $100, how much, without doing any calculations, how much money is budgeted for entertainment? 50. Why is it 50?
Because 10 is half of
10 is half of 20.
100.
Yeah, so then half of 100 is 50, right? So $50 on entertainment, $50 on what else? Clothing. Yes, babe. Can you take 10 times 5? Okay, and how can we get away with just taking 10 times 5? Because you can. But why? You know why? Because 1% is $5. But if you want 10%, you need 10 of those, don't you? So 10 times 5, that's why you can. Yes, you can. Okay, anybody else? Now, you're not going to make circle graphs, but you're going to have to do the calculating of what percentage of the pie should it take up. Okay, so let's go to the back side and actually, in a little bit here, maybe do that. Okay, now we're going into what are you going to, you have to make a decision when should you use what type of graph. So,
this is a good table to put a star by.
Your kind of star. Here's my kind of star. If data, then use. If data is organized into categories, then use a bar graph or a double bar graph. If you're comparing two different things, then the double bar graph. If the data changes over a period of time, as soon as you see that word time, line graph is a good choice. Okay, over time, line graph. Might be just a single line graph, it might be a double line graph, depending on what you're doing. And then if your data is comparing categories to a whole set, so like that last one, it was the whole budget, but how much got spent on each area, each category, then we'll use a circle graph.
So here they have one that they made, and it says use the data at the right to make a graph. Explain why you chose that type of graph. Well, we got a recipe for bubbles. The categories are bubble soap, dishwashing liquid, glycerin, and water. But it's a whole recipe for bubbles. So a circle graph would probably be a good representation of this one. And here they're showing us, this is the thing you're going to have to be able to do. Okay, step 1 and step 2. I'm not going to have you do step 3. I'm not going to have you actually make the circle graph. You're going to do step 1 and step 2. So you're going to figure out how much is in the whole, and then what part of that whole is each category making up. Okay? So let's go down here, and let's talk about what kind of graphs we would use for these situations. A bar graph, double bar, line, double line, or circle. Number 1, math scores of one student over the school year. There's some keywords in there.
Line.
A line graph. Why a line graph, Tony?
This is over the school year.
Yeah, there's time right there involved. So as soon as you see time involved, think line graph, okay? Over the school year. Okay, so we need a line graph. But then the question is, do we need a single line graph or a double line graph? A single. What could make it into a double?
If he has a brother.
Yeah, if you're comparing, a sibling or another student, comparing yourself to another student in this classroom or whatever. So we would say a line graph, and we are going to call it a double line. We're just going to have a single line graph. You can see if your math scores are, your line keeps rising, or if it eventually starts falling because you lose interest the closer it gets to the end of May, or who knows. It'd be interesting to do, wouldn't it? Okay, number 2. Attendance at an exercise class by age group as it relates to total attendance. Attendance at an exercise class by age group as it relates to attendance.
Double bar graph.
Double bar graph. Okay, well, what would be getting compared if we have a double bar? We got to talk about what are we comparing?
Right, it's total attendance.
Age group and total attendance. So we're going to we're going to put those two bars beside each other.
How
Age
many
group.
in each age group attend? So
Would
say
it
you
just
have,
be single bar, because one at H be there and then the attendance on the bottom?
Okay. There's some key words in here, you guys, that you're missing.
It says total attendance.
As it relates to total attendance.
So high.
A pie. The whole picture, as it relates to the whole picture. So attendance at an exercise by age group. So there might be an age group of, let's say, 15 to 20-year-olds.
Just an announcement, the high school track meet at Lisbon is canceled for today. Thank you.
That's good. There's lots of students I need in class today. Circle graph relates to total attendance. So each age group would have their own piece of the pie, showing how much the relationship of how many of them were attending compared to everybody. Okay, number of animals seen at a farm.
Okay, that'd probably be a bar, because you have different animals.
Yeah, each animal could have its own bar, and on the vertical axis, we would show how many of those animals. Would it be really easy to look at a bar graph and say, okay, they got a whole lot more cows at that farm than they do chickens, because the bar is a lot higher. So number of animals seen at a farm. This is a category. Each of them has their own bar, so this would be a bar graph.
So if it were a double bar graph, it would just be like,
How many black cows compared to
like
white
animals,
cows?
female and male.
Yeah, that would be a good representation, female, male. So number of animals, by gender,
Black color.
you can do it by color, white and black, I guess. You don't have chickens. Pigs, I don't know. Okay. Okay, so then our last thing we're gonna do here is we're going to actually decide, first of all, what kind of graph would we do for this one? A store owner uses an entire wall to display toys as shown in the table. Determine the percent of each toy for sale. What would this be?
Use a pie chart.
Yeah, this would be a circle graph. As soon as they say percent, your brain should say circle graph. So if I'm not gonna make you create it, but I want you to determine the percent for each. So step one, what are you gonna do in step one? Yeah, well, not to a percent, because we can't get them to a percent until we know what. Circle graph is comparing to a whole, yeah, so we need a total, don't we? So let's add first of all, and we're just gonna write down what we're adding. We're not gonna do this with the calculator. No, we're not ready for the calculator yet. We may not even need it at all, you never know. 10 plus 5? Plus 3? 18 plus 2? 20. 20 what? No. Shelves. Make sure you look at the table that they gave you. That is 20 shelves full of toys. Games are on how many shelves?
10.
10 shelves. So 10 of those 20 shelves are filled with games. So start visualizing this. You're walking into this toy store. Okay, step 2. We're supposed to figure out the percentage for each. So games.
Would you take everything times 5, because 20 times 5 is 100.
Okay, so if we put 10 times 5, that should tell us what percent. Okay. And the other way we could look at it, we could put 10 over 20 and say 10 is half of 20. So yes, we could. You pick out the way. How are you going to show your support for what you get? I like to do part over whole. There's 10 shelves of games out of 20 shelves. That's a half. That's 50%. And I didn't leave myself enough room. 50%. So it's going to take up what part of the circle graph? Half of it. Yeah, it's clearly going to take up half of it. Okay, puzzles. 5 shelves full of puzzles. 5 out of 20, which is, yeah, you're just doing it a different way than I am. 5 over 20 simplifies to what fraction? 1/4. 1/4 is what percent? 25%. That's going to take up what part of a circle graph? Okay, how much of the circle graph's already filled up? 75% of it, 3/4 of it, right? Yeah. So now we have our dolls on our trains. So the dolls, there's 3 shelves out of 20 filled with dolls. I bet you all know what 3/20 is as a percentage, right? What can we do, like Noah was talking about earlier? What can we do with that 20? Take it times 5. If we take that times 5, we take the 3 times the 5 and we get 15 out of 100. And 15 over 100 is the same as 15%. Percent is out of 100. 15 out of 100 is 15%. Well, last but not least, we could either do what? We got
What's left out of it?
yeah, what's left out of there? We got 90% used up, so how much is left?
10.
Yeah, we know it should be 10. So you'd either show that you add them all up and subtract, or just keep doing the process that we're doing. 2/10 is the same as, or 2/20 is the same as 1/10. A tenth is what percent? 10%. Now, you know you didn't do very well if all your percentages don't add up to what? 100. You gotta cover the whole circle. The whole circle needs to be done with all of the things that were supposed to be there. Okay? But you don't have to make the circle. Okay, questions?